Hello YouTube, what's going on? This is Arunava. In this video, we're going to talk about generators in Python, and I'm going to assume that you have some basic familiarity with what iterators are in Python. In case you need to get familiar or you need a refresher, you can go check the video out on the screen. And okay, with that, let's get started with generators in Python. Now, generators are a simpler way of creating iterators in Python. With generators, you don't have to worry about implementing a class to create a custom iterator. And you don't need to worry about implementing an iter and the next function, since you don't need to worry about implementing a class. And you don't need to worry about raising the stop iteration exceptions while checking for all the internal states inside the next function. And also, you don't need to worry about any of the other overheads that comes with iterators. Generator takes care of all of them for you. Simply speaking, a generator is a function that uses the yield statement instead of a return statement to generate value. That is, to return values to its callers. A generator can have more than one yield statement, but it should have at least one yield statement. So what it means is the presence of the yield statement inside a function is what makes a function a generator. Now, generators may also have a return statement without any value to indicate the end of the function. Okay, so next up, let's look at a typical generator. Now here you can see that there is a yield statement which is returning the yield value, and there is one more yield statement, so you can have multiple yield statements. And when the generator first runs, this for loop gets executed. So over here it's the range is from 1 to 5, so this yield is actually runs in the for loop again and again. And as you can see, you can have one return statement to indicate the end of the function. It's not necessary to have the return statement, but you can have it if you want. Now, the question is what the yield statement really does. That is, what is the difference between the yield statement and the return statement? Now, what the yield statement really does is it returns the value to its caller while pausing the current state of the function at that point, and later it gets resumed from that point on successive calls. So if we take a quick look at the function we had in the previous slide, so moving to the previous slide. Okay, so here you can see that there are multiple yield statements. So when the generator first executes, this for loop gets executed, and in this for loop this for loop gets executed 4 times with the value of 1, 2, 3 and 4. So for the first time it takes a value of 1. So on the first iteration, the iterator variable has the value of 1, and it runs the yield I, that is, it returns the value of I to its caller, and the execution of this generator pauses at this point. So at a later point of time, when this generator is called, the execution starts from this point, that is, the yield I is this iteration is completed, and the next iteration starts where the value of the value of the iterator variable is 2, and it again yields the value of 2 to its caller, and it gets paused, and for the next iteration it again goes for 3, and so on and on. Now let's now move to the next point of the yield, and let's see what it says. So it says that yield comes in handy when we want to iterate over a sequence, but we don't want to store the entire sequence in memory. So let's see what this really means, right? So if you go back to the generator function over here, so you can see a variety of values being returned, right? So in this for loop, the values 1, 2, 3 and 4 gets returned. Over here the two strings get returned. Now you imagine what would it take to return all these values without yield. That is, one function is returning all these values. So if all these values were to be returned without yield, then you need to produce all these values and store this inside something like a list or something like that, or some other data structure, and then you need to return all these together while using the return statement, right? So you need to store all of these values together inside the memory. So you can see the benefits of yield right here, right? So it is very memory efficient. You are returning one value at a time, and as soon as you're returning the value, you are not storing it anywhere. You don't need to store the value anywhere, right? So that is what is exactly meant by the second point. Okay, so now we have enough information. We can go ahead and start implementing our own generator and see how it works out. Okay, so let's get started with code. All right, let's write some code. So we're gonna just write the generator function that we saw in the slide, and we're gonna keep things simple. Okay, so def gen and and yield the values in each iteration. Okay, then yield, and we had one more yield which says something with war. I'm going to just keep it war, and the return. So the return statement, you can have it or else you can omit it. It's up to you. Okay, and let's then call the generator. Okay, now when you call the generator, this returns the generator object. Okay, the execution of the generator doesn't start yet, but it just returns the generator object. And as I said, so this returns the generator object, right? Okay, and you can print it to see. Should be there. You go, the generator object. Okay, now as I said that you don't have to implement the iter and the next, or you don't need to take care of the take care of raising the stop iteration when the values in the function gets executed, gets exhausted. So generator, that's the beauty of generators, right? It takes care of everything. Okay, so you can just go ahead and simply call the next function on the generator object and it will return the values one after the other. Okay, so let's do that. Okay, let's just simply call the next function on the generator object, and as you can guess, it will return the 1. So as soon as you call the next function, what really happens is the execution for the generator begins. And in this particular generator, the for loop, the iteration in the for loop gets started, and this iterator variable takes the value of 1 and it yields the value of 1 on the first iteration. And the execution of this function gets paused at this point. So it yields the value of 1. So so over here the value of 1 is fetched, it returns the value of 1 to its caller. So this prints 1. If you just if you print on this value over here, this would print 1, right? Control Shift B, and there you go, it prints 1. And as I said, the iteration the execution of this function is paused at this point. So when you call the next function on this generator object again, the execution will begin from this point, and the next iteration for this loop will start with the iterator variable having a value of 2, right? So you can see a dot next, and as I said, this should have a value of 2. So if I now run this, there you go, the value of 2 gets printed, right? And now the execution of this function is now paused at that point. So when you call the next function again, the execution will start again from that point, and the iteration will continue on taking the value of 3 and 4. And then when the iteration is completed, it will print the value of yield and then the value of woe. And finally, since all the values are printed, it will raise the stop iteration function. Yes, it takes care of everything, as I said, right? So let me just copy this, and so this would print 3, this would print 4, this would print yield, right? And okay, this would print woe. And now if you call the next again, this would raise the stop iteration. So let's now run this, and there you go. So first the value of 1 got printed, and then 2, 3, 4, and then yield, and then woe, and then stop iteration gets raised. Okay, now one thing to note is that you can use a for loop to iterate over this generator object. The reason is that the for loop takes an iterator and it uses the next function, which is also available in this generator object, uses the next function to get values one after the other, right? And it looks for the stop iteration exception to break out of the for loop. So let's look at an example using a for loop. So I'm going to comment these out, and let's look at an example using for loop. Okay, so for I in not range gen, and it's going to simply print I. Okay, so as I said, the iter and next all gets implemented and the stop iteration is accepted, and as you all saw, so let's go ahead and do it, and there you can see that it prints 1, 2, 3, 4 yield and woe, and it finishes, right? So you can do the same thing with using the for loop. Okay, next up, let's look at what are called generator expressions in Python. Now, what generator expressions are basically is that they allows you to create simple generators easily. Okay, and if you're already familiar with what list comprehensions are in Python, basically the generator expression is written just like that, except that in case of list comprehensions you are using you're using square brackets, and in case of generator expressions you are using parentheses, right? And a major difference between list comprehension and generator expression is that in case of list comprehension the whole list gets generated, and in case of a generator expression, what happens is that values are created as they are needed, one at a time. So that's the beauty of generators, right? So one at a time, and it's very memory efficient, as we already said. Okay, so let's just quickly look at some examples of generator expressions. So I'm just going to go ahead and say a, and I'm going to keep things very simple over here. So for I in range 1 to 5. So as you can see, instead of square brackets we are using parentheses here. Okay, so if I now print a, let's see what it says. There you go. Okay, this is the result from the previous one. There you go. So a is a generator object, right? And let's just use the next function to print the values in the generator object one after the other, as we saw in the previous example. Okay, if I now run this, so one is printed over here, and let me just copy it and paste it several times. And okay, too many, but it's okay. We'll get to see what's wrong. There you go. So 1, 4, 9, 16, and then the stop iteration gets erased. So you can use generator expressions, and they're very simple and they're very memory efficient, as I said, and you can create simple generator expressions. Generator is using generator expressions, right? All right. Okay, let's now list all the advantages that we saw that we can get while using generators. First point, yes, it's much simpler than iterators, right? So you don't have to worry about implementing a class while you're building a custom iterator. You don't have to worry about implementing the iter function. You don't have to worry about implementing the next function. You don't have to worry about checking all the internal states and raising the stop iteration exception, right? So it's much simpler than iterators, as we saw. Next, yes, it's highly memory efficient. So we saw the examples, right? So you don't have to store all the values that you're going to return. You can return all these values one at a time, right? It's pretty awesome. And yes, it can represent infinite stream of data, and this is something you didn't saw. So basically you can imagine a situation, right? So you have this let's say you have this generator, and inside this generator you can have something like a while loop, and inside the while loop you can increase some value of the variable by a certain amount in each iteration, and you can yield it, right? And so say there is no break inside that, so you are just returning values one after the other while increasing the value on each iteration. So basically you're representing an infinite stream of data, right, while not storing it anywhere. It's pretty cool. Okay, all right, thanks for watching the video. If it was useful, then do hit the like button and share it with your friends, okay? And before leaving, do hit the subscribe button. Okay, so bye-bye, take care, and see you all next time.